Welcome to Manifested Publishers.
Hello learners, welcome to chemistry lesson. My name is mmHg. We are learning chemistry and the topic is gas laws. Remember, the forum is still manifested online classes. In our previous lesson, we derived the formula for Boyle's law, where we said that V1 P1 is equals to V2 P2. And we said that V1 is the initial volume, P1 is the initial pressure, V2 is the final volume, and P2 is the final pressure. That is the formula we will be using to do some calculations involving Boyle's law. In this lesson, we are going to discuss the units of pressure. We want to discuss some of the units you can use to measure pressure with. The standard unit of pressure is called Pascal. The standard unit of pressure is Pascal. So Pascal. That is the standard unit of pressure. 1 Pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared. So 1 Pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared. Therefore, we can say that 1 Pascal is equivalent to 1 Newton per meter squared. 1 Pascal is equivalent to 1 Newton per meter squared. Another unit of pressure, pressure can also be measured using atmospheres. Using standard atmosphere or just ATM, so abbreviated as just ATM. Can also be measured using standard atmosphere. And we say that 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. That is another unit of pressure. And lastly, pressure is also measured using millimeters of mercury. written as mmHg. Remember, Hg is the chemical sample of mercury. So these are also units of pressure. And they say that 1 atmosphere pressure is equivalent to 760 millimeters of mercury pressure. 1 atmosphere is equivalent to 760 millimeters of mercury pressure. Therefore, those are our 4 units of pressure, which are pascals, being the first one. The second, we have said, are newtons per meter squared. And we have this illustration, or this illustration where we say that 1 Pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared, meaning it's an area of 1 meter by 1 meter, so that it is 1 meter squared. The third unit is standard atmosphere, or just atmosphere, standard atmosphere. And again, we've said that 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. Those are units of pressure. And lastly, I have said that you can also use, or pressure is also measured using millimeters of mercury. And I have said again that 1 atmosphere is equivalent to 760 millimeters of mercury. So always understand those relationships, because again, sometimes you'll be required to convert either millimeters of mercury to atmospheres, or atmospheres to millimeters of mercury. I also want us to do some applications or some examples of Boyle's law. So we now get some examples or the applications of Boyle's law. And the first example I have this example. Let me write it for you. What is the first example? So if 60 centimeters cubed of oxygen is compressed from 20 atmospheres pressure to 40 atmospheres pressure, what is the new volume of the gas at constant temperature? So temperature must always be constant. Let's do the question. So the solution would be, so first of all, you need to understand or need to know the expression or the formula for calculating Boyle's law. And we say that the formula is V1 P1 is equals to V2 P2, where we say that V1 is the initial volume, V1 is the initial volume, P1 is the initial pressure, V2 is the final volume, and P2 is the final pressure. So in our case, we have the first volume, or V1, is 60 centimeters cubed. P1 is 20 atmospheres. V2. This is now what we are looking at, or we are looking for, and P2, final pressure, is 40 atmospheres. 40 atmospheres. Therefore, we still have our formula V1 P1, which is equals to V2 P2. We want to make V2 our subject. Therefore, we have to divide this one by P2. Then we divide this by P2. When divided by P2, this P2 will cancel out on the right side. And you'll be left with V1 P1 divided by P2 is equals to V2. Therefore, you get the V2 from this. And you already have the V1, P1, and P2. Therefore, you just need to substitute. V1 is 60 centimeters cubed, multiplied by P1, which is 20 atmospheres. You divide by P2, which is 40. This one, if you calculate using your calculator, it will give you, that is now 60. You multiply by 20. $60 multiplied by 20, it gives you 1,200 divided by 40. And this gives you 30. And therefore, our V2 is 30 centimeters cubed. It is important to include the units because we are calculating the volume, and this volume is in 30, or is in centimeters cubed, sorry. It's in centimeters cubed. So it is important to include the units of measurement. That is the first example. I want to give you the second example so that you understand better. The second example is a certain mass of a gas occupies 500 centimeters cubed at 100,000 pascals. What will be its pressure? What will be its pressure at 1,000 centimeters cubed? Solution to this, remember our expression is still V1 P1 is equals to V2 P2. And our V1 is 500 centimeters cubed. P1 is 100,000 pascals. V2 is 1,000. P2 we don't have, and that is what we are looking for. Therefore, using the expression V1 P1 is equals to V2 P2, we don't have P2, and that is what we are looking for, and therefore need to make P2 our subject, and we'll make P2 the subject by dividing both sides with V2. Divide both sides with V2, then this V2 will cancel out, and you will be left with V1 P1 is equal, you divide by V2 is equals to P2, and P2 is now what we are calculating from our question. The next step, you just need to substitute. V1 is 500 centimeters cubed. You multiply by P1, which is 100,000 pascals, divide by V2, which is 1,000. Therefore, if you do the calculation using your calculator, that is 500 times 100,000 that gives you 50 million. And divide this by 1,000. You will get 50,000. 50,000, because you are looking for pressure, then you must include the units of pressure. Therefore, it's 50,000 pascals. That is how simple the questions are, and therefore you should be able to do as many questions as possible, so long as you have the expression V1 P1 is equals to V2 P2. That will be a very great equation, or very important when you'll be doing the calculations involving Boyle's law. That is our lesson for today. But before I end, I want to do a small recap on whatever we have learned. We have learned the units of pressure, which are 4. It can be pascals, can be Newton per meter squared, can be standard atmospheres, and millimeters of mercury. And we have done 2 applications of Boyle's law. The application number 1 was if 60 centimeters cubed of oxygen is compressed from 20 atmospheres pressure to 40 atmospheres pressure, what will be the new volume of the gas at constant temperature? And we have our expression V1 P1, which is equals to V2 P2. Then from the question we have isolated, V1 is 60 centimeters cubed, P1 is 20 atmospheres, V2, this is what we are calculating, and P2 is 40 atmospheres. Therefore, because we are looking for, or we are calculating V2, we need to make V2 the subject of the formula. Therefore, from this expression, we have to divide both sides by P2. Therefore, on the right side, the P2 will cancel with the P2, and the V2 will be left as the subject of the formula. And that is now what we have at this point. Now from there, the next step is substitution. That once you substitute, then V1 is 60, P1 is 20, P2 is 40. Therefore, 60 times 20 is 1,200. To divide by 40, this will give you 60. And therefore, the V2 is 30 centimeters cubed. And I've told you again that units, again, you must include the units because they are so important. That shows that those are the units of measurement of volume. In the second example, was a certain mass of a gas occupies 500 centimeters cubed at 100,000 pascals. What will be its pressure at 1,000 centimeters cubed volume? Therefore, again, expression V1 P1 is equals to V2 P2, where the V1 is 500 centimeters cubed, P1 is 100,000 pascals, V2 is 1,000 centimeters cubed, then P2 we don't have, and that is what we are calculating. Therefore, because we are calculating for P2, we need to make P2 the subject of the formula. Therefore, you divide both sides by V2. Then when you divide both sides by V2, now this V2 and this V2 will cancel out, and you'll be left with P2 as the subject of the formula. And you now do the substitution. V1 is 500 centimeters cubed. Then you multiply by P1, which is 100,000 pascals. Then you divide by 1,000, which is the V2, and you'll get 50 million divided by 1,000, then you'll get 50,000 pascals. Again, the units are so important, you need to include them at the end of the calculation. So that is the end of our lesson. But I'll leave you with one more question as your assignment. And this is the question. The assignment is, at constant temperature, a gas with a pressure of 750 millimeters of mercury occupies a volume of 80 centimeters cubed. What will be the pressure of the gas if it is expanded to occupy a volume of 340 centimeters cubed? That is the assignment. Therefore, ensure that you've done the assignment before we meet in the next lesson. Thank you for being part of the lesson. Bye. We meet in the next lesson where we do some more calculations involving Boyle's law. Thank you.